Greetings and welcome to my Zend Framework 3 tutorial series where I will cover the newly released and much improved framework from Zend. Two changes that I believe made Zend Framework 3 that much better than 2 are splitting into components and Service Manager using proper dependency injection pattern style. Now, you don't need to go through troubles of installations. Every component is shipped in an individual package that is managed through Composer, and they truly can be used independently of each other with no unnecessary dependencies of seemingly unrelated pieces. If you are new to Zend Framework 3, you do not have to worry too much about whether you made the right choice. Unlike before, where you needed to choose a framework based on how well it will do everything that you needed at once, making compromises where it couldn't because you couldn't reliably download additional components from other sources, here you have a choice between picking components that are available in the Zend Frameworks repository, or if you, for example, don't like the way Zend deals with login or email, you are completely welcome to get that component from somewhere else. Documentation improved a lot, so I will frequently refer to it to show how best to extract the most useful pieces. To get started, we're going to head over to docs.zendframework.com, tutorials, head down to getting started with Zend Framework. First part is talking about setting up the web server and the database for their tutorial. Not overly exciting. I'm going to skip that. And here's the information that we actually need, how the Composer project is structured. It's telling us that to get going, we need to run Composer, create project, and you probably do not have to put .far in the end if you set up your paths correctly. I just do because that's how mine work. -s dev Zend Framework Skeleton application is actually path that you will find in the packages for it. And where we want to install it, which is in our ZF tutorial directory that is empty. Now Composer is downloading. Once it's done, it has some questions for us. Do we want a minimal install? No, because we do want to take the opportunity for conveniently adding additional features. Developer toolbar, yes, that could be somewhat useful. Do we want caching support? Yes, because doing it by hand is quite difficult and annoying, so having a convenience for it to do it for us is really good. Zend database, yes, we are going to get to that sometime later. Forms support, no, we're going to practice doing that manually. JSON serialization is always good, especially for APIs. Login support, absolutely. MVC-based console support, not right now. Internationalization, going to be useful for a parallel Russian version of the series. So no for this one. Other plugins we're going to install manually as need arises. PSS7 middleware will not be the focus. Session support, yes, eventually. MVC testing support, absolutely. And a little disclaimer, I actually wrote the testing skeleton. DI integration, which is the old-fashioned dependency injector, in favor of Zend Service Manager, no. Letting it finish the installation. Now we have questions about configurations. Since every component is independent, there is slight difficulty in how we want to merge all the configurations together without overwriting your previous work. Right now it's asking us where should the configurations for Zend developer module go? In here, between 1 and 2, we have a hint that there will be two modes eventually, production and development. Developer tools are probably going to be only useful in a development environment, so I'm going to say put them in the development version of the configurations. Not going to remember that for other pieces. Zend Cache is going to be useful for both development and production. It's going to have different settings, yes, but it will definitely have configurations in both, so I'm going to put it in one, in a general configuration. Now again, ZendDB also, despite having both production and local settings, is going to be a generic component that's applicable to both. So one to that. ZendLog, same deal. Session, yes. And do we want to remove Git history? This is Git history from the development lifetime of Zend Skeleton itself. We want our own history with commits that are relevant to what we are doing, not what the Zend team has done. So we definitely want to remove those, and we're going to start from scratch. Well, let's see where this got us. Further down in the official documentation, we are eventually told that to get to the project from the web browser, in the built-in web server, we need to get this in. So let's do that. php-s, I'm going to bind it to that address, port 8080, t public index. We see the PHP server has started. Bring the browser for development in focus, and off we go. Here is our Zend Skeleton working. Of course, this does not conclude our project. This is probably not what we're getting paid for. We now have to connect our IDE to that directory. I'm going to use PHP Storm for this, creating a new project from existing files. In ZF tutorial, I will make sure that my PHP version is 7, interpreter is 7, the same one that the built-in web server is on. Create. Bring that into focus. Latinate index. And let it deal with PSI0. It detected the test folders pretty accurately, and the source folders not so much. We are going to make sure it only treats the module application SSC as the sources, others as libraries. Okay to that. And now let's look at the structure. From the top, we have our config folder that has the application configurations. Modules config PHP describes what all components are loaded. This will include all the modules that you create yourself, such as application, sits inside of the module folder, all of the Zend individual components, or any third-party components you will bring in. Following that, we have development.config.php to Dist. This comes from the production versus development environment I talked about earlier during the composed installation. Here it's disabled. So by default, right after skeleton install, it is not in a development mode. It is actually in production mode. So modules such as Zend Developer Tools are not enabled. Also, please note that production mode enables configuration caching. Therefore, any code that you write may not work because configurations are cached and your new changes do not get applied. To turn this on, we are going to follow the last part of the installation instructions, that is Composer Development Enabled. And before that, as a practice, we're just going to show what status we're really in. Composer Development Status. Here it's actually telling us development is disabled. We are going to enable it. I'm now in development mode. Let's see how that affects our configuration directory. Development config.php has now been added. And it is now going to be merged with the overall application configurations. And caching, most importantly, going to be disabled. So now any changes that we do make will be visible. How does that affect the page? We have the DB complaining. That's most likely because the Zend DB has not included its configs. We're not going to get into detail of the database configurations until somewhat later. So we're going to satisfy it real quick by going to autoload global PHP and return a simple DB key. It's actually going to give us another error complaining about driver missing. And we eventually will be using PGSQL driver. And now everything should be happy. There we go. And we even got our development bar underneath. How does Zend Framework know where to load those modules from? That it figures out from application.config.php. Module paths is where it looks for source code for the modules that are described in the modules.config.php. Here we have module being at the top. That's the module directory. Therefore, application is going to be found. And for other ones listed, Zend sessions, Zend logs, Zend DB, and anything else that you will insert manually through Composer later on goes in the vendor. Getting used to error messages and being able to handle them is very important. So I will demonstrate the most common mistake that I make of forgetting to load the modules. So if I install something through Composer, I add it, it's installed, but let's say I forget to actually instantiate it in a modules configuration. I'm going to peek at the router, and let's see what happens if I forget to properly configure it. It's going to complain that that module is not found. Router plugin manager was not available and service manager wasn't able to load it. Why it wasn't able to load it? Because I didn't tell it to load it in my modules config file. And now it's working again. Some more points of interest are config cache enabled. We talked about that earlier with development versus production. This will be all revisited in due time. The actual caching is stored in data. So when we do eventually get to deploying it, make sure data is writable. And then we'll go to the actual module. This is where our source code will live. Expanding the first folder in our module that comes by default is yet more configurations, module.config.php. Yes, Zend Framework is very configuration heavy. I consider that a benefit because my brain just happens to not deal very well with procedural or functional programming styles, where you may find a function that says, okay, load this module, then load this route, then load these classes, then load this action. my brain doesn't really deal with that very well. I prefer a configuration style that describes how the application should work, and then the framework will assemble that configuration into an actual functional application for me. Some people don't like that, so that is a very personal preference. It's not bad or good. This is purely subjective. Here, Skeleton Installer supplies us with a router, which is a component that translates what we type in our URL to the actual classes in our sources. For the moment, all it does is it takes the root of the URL and assigns it to index controller, and anything we type after that is going to be a method within that controller. The actual controllers getting instantiated through a factory. That's going to be service manager job in a second tutorial. Some more configurations for the view, to revisit that in a view tutorial. The module itself is loaded through module PHP file. Every module absolutely must have this file. It will be in a namespace of the directory it's under, the same namespace that is specified in a modules.config.php, a very important connection. Modules config PHP application lives in the application directory, has a namespace application, and is found by composer to loader through PSR4 path application module application SIC. So that's how files are found in general. Module config specifies what should be loaded. It then knows that it must look for a module file with this namespace. How is it going to find this file? It's going to check with Composer that says, hey, where does application live? Application lives in module application SIC. So then it's going to actually load the file. It then going to load the configurations for that file, and application turns on. Now's a good time to see into a bit more detail what's happening inside of the class that actually delivers our application. Going over to index controller, the one that our router says needs to execute when we hit the root of the URL. We'll put a breakpoint in there. Make sure that the IDE is listening for Xdebug connections. They have been set up ahead of time through my PHP configuration. Refresh that, go back to IDE. There are important features of the index controller that are worth looking at. First one to pay attention to is the event object. This gives us a hint that Zend Framework is very much event-driven framework. That means it's not just about function colon another function colon another function in a procedural style. It's more of events. We configure the framework to listen to particular events or states or actions. So we say, when you notice that this particular thing is happening, you run this class. And a lot of the code is written in this way. So in this particular case, the MVC component, the model view controller component, has a bunch of special occasions. It starts up, it does some stuff, it dispatches, and then it does some more things. In this particular case, the dispatch event of its life cycle is what causes this controller to actually execute. So again, MVC starts up, it does something, those functions handle whatever it does, then it says, okay, I'm dispatching, and once this dispatch event has been broadcast, whatever is registered to listen to this dispatch event is going to execute, and in this case, it is this controller that gets executed during a dispatch event. Once it finished executing, the controller creates a response object. The response object, in short, going to consist of the actual thing that we're looking at, all the HTML code or JSON code or any output. But there is no output to be seen in the syntax controller. So where is it coming from? So the next part that the skeleton installer has done for us is create a configuration, yes, yet another configuration, that matches the names of actions with names of view templates. In this case, the application index action is getting matched with application in the view folder this time, index p.html. p.html is the convention for templates, just to make a difference between PHP that is something that you do in a business logic versus PHP something that you do to generate your HTML code. So let's look at what that does. We can navigate to it directly, or we can expand the view folder. Here we got some more controls and actions that the skeleton has generated the views for. In our case, it's the application, index PHP HTML, same one. And we notice that this is the output that's provided by the controller, but it's not quite extensive. We only see a piece of it. So what else does the skeleton did for us? Well, the skeleton also created a layout directory with layout.html, and this is actually coming from a component Zend View. So instead of installing Zend View manually and configuring it manually, the skeleton installer has downloaded and installed it for us and configured it so that the individual action templates are magically wrapped inside of the layout, specifically right inside of this content variable. And we can see it for ourselves. If we go around here, we inspect this element. There we go. That's our Jumbotron. That's the class by the Bootstrap framework. That's Skeleton also kindly provided to us by default. And right there it is. We see the container and the rest of the content underneath it. Back over to the controller class, we have another very important property of it, and that's the request. The request describes to the controller what the user has entered. So that includes both the HTTP headers and any direct input. That would be either forms or post or get in a URL. You can see that right here. We got a get method. So that means we entered to the controller through the URL bar. We gave it just the slash, and we did not give it any parameters. That's a subject for the actual MVC tutorial. Before we go too far away from the front-end pieces, the response, the request, we need to look at the public directory. Public directory has a single entry point index.php. This is what the web server going to forward all the traffic to before it gets broken down into pieces for the router to examine and decide what controller and action to go to. Not a whole lot here, just verifying that Zend Framework is installed, and if it's not, we're going to give a hint how to install it, and then loading the configurations from the file system and passing them into Zend Framework's application execution environment. Overall, this is where the browser is going to download all the assets for CSS, images, or even JavaScript applications. We can put a whole single page application here if we choose to, probably not recommended, but if we do progressive enhancement style where we have mostly HTML code that gets augmented with additional JavaScript functions, all of that can go underneath the public directory. Going to let the debugger go through. and look at the last directory in our list. Even though it's last, we're actually going to work with it first the next time we do any actual coding, is the test directory. This is the feature that I have added to the skeleton myself. So if you don't like it, if you have any problems with it, please let me know and I'll improve it as best as I can in a pull request to the upstream framework. The purpose of this file is to verify that whatever changes we make to the controller in the future will continue to work. Additionally, it actually helps us to structure our ideas. If we can create a test that exactly describes what the program should do, it is significantly easier to actually write the code that does that. At a quick glance, this test verifies that the index controller can actually be accessed given the configurations that we supplied, that it throws the error when we do something wrong, and that the template is actually generating a proper CSS class so that the designer can make it look pretty. Major difference between a test and the module that's part of the parent application is the fact that configurations may be slightly different. This controller actually gets executed by itself without loading the rest of the application. That's very important for a unit test. We verify that the function works in isolation so that we do not have unexpected errors when we change something else we think is unrelated. So how do we manage to get these configurations that are so important into this class that runs by itself? Well, we are going to merge them in by manually bringing in only the ones that are specifically necessary to run it. If we need to modify it, we can do so very quickly just before we start the test. These configurations are getting recreated at the beginning of every test that gets executed and deleted at the end of each one. To run the tests, we're going to turn off the debug listener for this case. We can either do so through the command line, and that's most likely how our build server will be able to do it. Vendor bin PHP unit. We see the 3 tests run. Or, much more conveniently, the way we will do it on a daily basis is to create a PHP unit configuration runner. We're going to say, defined in the configuration file, we are going to pick one from here. We're going to, for some reason, again specify that we're using PHP 7. We're going to now say that we're using a PHP unit version that comes with Composer. It lives underneath vendor autoload PHP. Okay to that. Okay, some more. Should give it a better name. Unit test. When we run it, we see all 3 tests pass. And if we actually want to see how they work in detail, put a breakpoint. We say debug. We see that it passes through the index action. And we can inspect what our unit tests do after that. On the last note before we wrap this up, notice that we have this recurring theme of something.dist and something that is, well, not dist, the real PHP file or the real XML file. These dist files that you see sprinkled all over the directory by the skeleton installer, there is some more in the autoload directory, are meant to be committed into your central repository and seen by other people. The files which have the same base name but don't have the dist, they are meant to not be committed into the repository but remain local. The point of this is to give other developers opportunity to create configurations that suit their own development environment. So, if you have multiple developers that have their own version of test databases, you need to make sure that they have opportunity to put their own passwords, their own database server addresses, but you still need to somehow describe to them what a configuration should look like with blank data. So the blank configurations with blank data go into the dist file, get committed to the repository for everybody to see. Then the developers to whom this project goes to, they will copy the dist file into the equivalent files without the dist extension. We've seen this when we switched away from the development mode into production mode, and the skeleton installer took the dist away and created one without it. Those will get the configurations just for ourselves. And so we conclude our walkthrough of Skeleton installer. I realize this may not have been the most exciting tutorial. All we've done is just look at what's already there. We haven't created anything new, but it was a necessary step to get familiar with the environment, to see what's important, to understand what to expect. But now we can get to making our own modules and use the most important component, the service manager, next time.